Before we look more closely at acids and bases, we're going to review a little bit about dissociation. So, you recall, dissociation is essentially how much a compound breaks into ions when we put it into water. So if we put a compound into water, does it break completely into positive and negative ions? So that would be our strong electrolytes. Does it break apart partially? So we have some that are plus and minus, and some of them that are the whole compound still. Or is it a non-electrolyte, so it doesn't break apart at all? So these are going to be important as we look at the different types of acids and bases. So first we're going to look at something similar to the strong electrolyte, which is our strong acids. So strong acids, they react in water to completely break apart. So this HCl breaks apart into H plus and Cl minus. So these are AQ. Now, you notice here that I have it written as H3O plus. That's because there's water here. And this H plus is going to immediately react with water to form H3O plus, or the hydronium ion. Now, this is because of what H plus is. So this reaction goes to completion because we're talking about a strong acid. So hydrochloric acid is going to completely dissociate in water to form hydrogen ions, which are then going to bond to water to make H3O plus and Cl minus. Sometimes you'll see online it written interchangeably in this form here or in this form. Essentially, it's just different ways of writing our acid here. But there's a reason why this H plus immediately bonds to water. If you think about what H plus is, a hydrogen atom, we have a positive, we have our proton in the nucleus, we have our electron outside of it. So this is our hydrogen atom. When the hydrogen atom loses this electron to become H plus is just that proton. So sometimes you'll hear the hydrogen, so H plus, also called a proton, because all it is, it's a bare proton. This is also called the hydrogen ion. This H plus, it's going to be attracted to the first water molecule it can find to form H3O plus. And this is also called the hydronium ion. So let's take a look at what this strong acid in water, how this actually affects some of our calculations that we did with it. Now, often when we're talking about acids and bases, we're going to talk about pH. So pH, it's a scale, it's a logarithmic scale, and it goes from 0 to 14, and it tells us how acidic something is. The lower the number, the more acidic. The higher the number, the less acidic. So if the pH is below 7, where we say that that's an acidic solution. If it's above 7, it's basic. And if it's at 7, it is a neutral solution. We'll get into this a lot more. To calculate our pH, we use the pH is equal to the negative log of our hydronium concentration. You may also sometimes see pH as pH is equal to the negative log of H plus concentration. These are interchangeable forms of the same equation, because remember, H plus is going to attach to water to make H3O plus. Okay? Don't want you to get confused by the different ways that these are found in the world. For a strong acid, the concentration of our H3O plus is going to be equal to the concentration of our strong acid. because of that balanced equation we looked at before, where our HCl is equal to our H3O+. So notice that there's no coefficient here, so it's a 1 and a 1. So these are mole ratios, just like we do in any other balanced equation. So for every 1 hydrochloric acid, I get 1 H3O+. So these are going to be equal values. You can prove that to yourself by doing a mole-to-mole calculation. So our concentration of H3O+ is going to be equal to our concentration of our strong acid. So if our HCl is equal to 1.2 times 10 to the negative second molar, I can simply substitute in the concentration of my strong acid into my pH equation and solve and get pH equals 1.9. Probably one of the bigger challenges folks have with these pH is learning how to do logs on your calculator. Do keep in mind that your pH should typically end up somewhere between 1 and 14. That's a way you can check your value. If you get something outside of that, you want to double check yourself and figure out where you've gone wrong.